My phone. Dum, da, da, dum, 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 dum. Let's see if this worked. It did. Can I hear myself? Because that's the issue. And I got to do a check every time. Okay. Cool. Cool, 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 cool. Mm. I know I say 4 o'clock, and then I'm always late. Cool. Already have everything up and running because we are going to jump right into it. So last week I personally read chapters 1, 2, and 3 from the AWS study book. So again, I'm doing live streams of the AWS Certified Solutions Architect exam, associate exam, differentiator, associate exam. I have a study guide. That is what I'm using as a reference to read. But in addition to the study guide, I have access to Linux Academy, which has some demos, cloud demos that I'm doing. I have some practice tests that I'm also doing on a Zoom call with some other study group people. So I have a bunch of different mediums. But for this purpose, we're just going to be using the textbook today. I want to do some notes for chapter 4 and then answer some questions and kind of go from there. Nothing too crazy. Chapters 1 through 3 were about an introduction to AWS. So that covered like best practices about architecture. It went into hybrid architecture, really talking about the different services, identifying what the services are. And then chapter 2 dived into simple storage service, which was Amazon S3 and Glacier storage, and like which should you use, how to design cloud storage services, how to identify and recognize, architecture considerations. Chapter 3 was about Amazon Elastic Cloud, Compute Cloud, and block storage, which is about designing highly available, cost-efficient, fault-tolerable scaling systems, implementation and deployment, data security, all of that good stuff. So today is going to be chapter 4. Chapter 4 is about Amazon Virtual Private Cloud. This week I plan to do chapter 4, 5, and 6. So my goal is to try to do 3 chapters a week. So that way I can finish this book in particular by the end of the month. And then by, I don't know if I'm going to schedule the test at the end of the month because it's a lot of pressure. I haven't decided yet. I say I'm going to. The reason why I'm going so hard is because I would like to do the test by the end of the month, but I don't know. Cool. Hi. Someone said it's their first time watching. Thanks for joining. I do have, I don't think the stream from last week is not up because I think that's solely on Patreon now. I kind of keep it up for 24 hours, but this one will be available for 24 hours as well. And I kind of just do study notes so people can see how I study, which isn't really efficient for everybody, mainly because I'm a skimmer. And I like to practice. I really like to get my knowledge by like doing stuff in the platform, but I also understand that I'd be missing key important terms by skimming. So I'm going to try not to do that this time. I skim because I get bored, but I'm going to try to take as much good notes and set a good example for you guys as possible. Okay, cool. So what are we covering within Amazon Virtual Private Cloud? We will be identifying and recognize cloud architecture considerations, such as fundamental components and effective designs. No shame on you. It's okay. I misspell things all the time, like all the time. We're going to get familiar with best practices, some trade-offs, hybrid architecture, which is really important because hybrid cloud is essentially the way of the world for everybody, simply because solely being on premise is unrealistic, and then not everyone is able to be cloud native, right? We're still pretty early in maturation for a lot of companies to be fully cloud native. Only if you'd have to be like a startup or a company who's willing to start from scratch to be cloud native. So hybrid architectures are something that's super, super important. Hi, thanks for joining. That went fast, sorry. Domain 2 is about implementation and deployment. We get into Amazon EC2, S3, Elastic Beanstalk, a whole bunch of different services, data security as well, which if I'm not mistaken, that was also on the last one. But let's just dive into it. So this is the introduction. Okay, cool. So their introduction is Amazon Virtual Private Cloud is a custom-defined virtual network within the AWS cloud. You can provision your own logically isolated section of AWS, similar to if you were designing and implementing a separate independent network that will operate on an on-premise data center. So VPCs is the equivalent to a data center in the cloud for AWS. This chapter is going to explore the core components of Amazon VPC. We're going to do some exercises, learn how to build it in the cloud, and get a strong understanding of Amazon VPC topology and troubleshooting. All right. So Amazon VPC, networking layer for Amazon Elastic Compute Cloud, which was in the chapter before. So I definitely recommend going back to really understand about compute and some other services that really build upon each other as you keep going within the chapters in this book. And it allows you to build your own virtual network within AWS. You control various aspects of your VPC, including your own IP address range. Creating subnets is really important here, configuring route tables, network gateways, security settings, all of that is included within the VPC, and you are in control of all of that. Within a region, you can create multiple VPCs. So if you're familiar with regions and availability zones are a subsection, or I should just say a piece of a region. So for example, a region would be, we can say Europe, right? And within Europe, they can have different aspects, or I could use the United States because I'm in the United States. So a region could be US. The US is one region. And within that region, we have different availability zones, which are like US East 1, US East 2. You have US West, Central. I think that's it, right? It's East, West, Central. I'm not sure if I'm pretty sure they haven't divided into like South or not. But those are typically the main regions whenever you kind of have within the US or North America or Asia or Europe, you'll have a Asia East XYZ, blah, blah, blah. You can create multiple VPCs, which means you can create multiple networks within a region. Now, when you create an Amazon VPC, you must specify the IP4 address range by choosing a CIDR block, such as 10.0.0.0/16. The address range of the VPC cannot be changed after it's created. So I personally would highlight that as a key note. I'm not going to say that's a term. So the way I kind of divide my notes out is I have key terms, and key terms is really just for my reference. So these are words or concepts that I'm familiar with, but I don't need to write a definition for, whereas notes is something that's a little bit longer for me. So like I would want to put this as a note where the address range of a VPC cannot be changed. Why can't I spell? After a VPC is created, which means that is forever, which really makes sense, but I'm not really, I should say network isn't my strong suit. So therefore, gonna write that down. Cool. A VPC address may be as large as a /16, which is 65,065.5 available addresses, or as small as a /28, which only has 16. They should not overlap, which makes sense. What else can we get from this? The VPC service was released. Oh, I'm starting to skim. Okay, hold on. Because of this, there are two different networking platforms available within AWS. Okay, cool. So Amazon VPC service was released after the EC2 service. And because of this, there are two different network platforms available within AWS. You have an EC2 Classic and an EC2 VPC. So I would write that as a as a term. So EC2 Classic versus EC2 VPC, two different networking platforms. EC2 was originally launched with a single flat network shared with other AWS customers. As such, AWS accounts created prior to the arrival of the VPC can launch instances in the classic network. AWS accounts created after December 13th only support launching instances in the EC2 VPC. So I wonder if you need to know that. Yeah, I wonder if that's relevant, simply because if you can't launch anything after December 2013, then I guess for those, there might be some customers who might be in AWS prior to 2013 and might have this situation, but I want to go out and say that is a very small subset of people. I'll leave it there though, you know. All right, cool. What else we got? So this is a VPC subnet and route table. As you can see, we have subnet 1, subnet 2. Subnet 1 is within availability zone A. Subnet 2 is within availability zone B. And then both of these are within a VPC, which is within a region. So like I said before, you would have a region which would be considered maybe like US. And then within that region, you would have US East, which can be this availability zone here. And then you would have maybe US East A or something like that. So that would be another availability zone. And Amazon VPC consists of the following components. It has a subnet, a route table, a DHCP option set, security groups, and ACLs. So that is something I would also highlight. So VPC is always going to have, VPC always consists of a subnet. Oops, do I want to list that out? I'm going to do this like this. A subnet, a route table, a DHCP option set, security groups, and a NACL. I call it a NACL, but I'm not sure how people pronounce. And ACLs, I guess. There's also some optional components, which I would put. So optional are, I'm going to put, I want to learn abbreviations and not rely on, because that's how they'll trick you on the exam, is where instead of saying internet gateways, it will be IGW. And if you don't know what an IGW is, then you'll be like, girl, I don't know how to answer this question. So EIP is elastic IP address. ENI, which is elastic network interfaces. And then you have endpoints, peering, network address translation, and NAT gateways. Cool. What's next? Wait, is that also optional? Okay, more optional stuff. And I want to list this out. Sorry, I'm pretty particular about notes and how things are like aesthetically pleasing and set up. And it's easier, right? If you're able to read your notes, it's easier for you to get the information. So I'm gonna list mine out because I think I was trying to save space, but this is a digital. I use Notion for my sets. I use Notion for everything. Notion is like a heaven sent product, okay? Because they do all the things that I need them. I have all of my stuff here. So cool. So I'm gonna say always consist of this, and then these are optional options. I don't know how to put that, so I'm gonna just leave that for now. Keyboard Slayer says, I always say out the whole word under my breath when I learn abbreviations because so many abbreviations in IT. I totally agree. Like in IT, in security, in general, there are more abbreviations than I think are necessary for things. But unfortunately, they use abbreviations to test you, especially on exams. They won't. So like the fact that they put VPG and the CGWs and all of these means that they're going to have them on the exam. You'll definitely get a question where it'll be, I've had a question where it was just all abbreviations. And I was like, oh, y'all trying me. Like, y'all, that's too much for me. So yeah, I agree with you. I have to say them and write them down and like reiterate them. Okay, so in addition to the NAT gateways, they also have a VPG, which is a virtual private gateway. Okay, I'm tired of typing abbreviations now because now I'm getting tongue-tied. CDWs, which are customer gateways, and then VPNs, which are pretty easy. I don't really need to know. I know what VPNs are. Cool. Subnets. Ooh, don't like this subject at all. That's why I don't work in networking like that. I know about networking enough to get a job done, but I'm not a networking guru and I do not want to be. Okay, so a subnet is a segment of an Amazon VPC's IP address range where you can launch Amazon EC2 instances, you can launch databases, other resources, XYZ. An example of a CIDR block would be 10.0.1.0/24. The smallest subnet you can create is a //28. Amazon, so this is a question that was on, so I have a weekly study group, a Zoom call study group with some people on Sundays, and this was definitely a question that they had, which is how many IP addresses does AWS reserve? So they reserve 4. So how do I want to separate this? So I'm going to turn this. So this is why I like Notion. Notion allows me to turn different things into different facets. So like, for example, I kind of have this out in bulleted wise, but I think that takes up a lot of space. So I can turn it into a toggle and there you go. And that way I can kind of just toggle between notes, which I usually typically always do if it's something that's pretty long. So I'm going to leave it like that. So Amazon AWS reserves, actually, let me do this. This is a subnet section. And within subnets, I'm going to make some bulleted notes. So AWS reserves the first 4 IP addresses and the last IP address of every subnet. And I'm just going to put in parentheses for internal purposes, just so that way you're aware. All right. So for example, a subnet defined as a /28 has 16 available IP addresses. If you subtract the 5 IPs needed for AWS, that means you only have 11 IP addresses, which is useful to know, right? Because if you are an administrator who is setting up a network and you need, we'll just say example, 30 IP addresses in order for like you to give out to the different devices within your network. If you use a /28, that means you only have 11 IP addresses and therefore that wouldn't work for you. So as a network administrator, you definitely need to know like how many IP addresses you need and therefore which CIDR block would be appropriate for the environment that you're creating. I should write that down because I feel like I'm going to forget that. The smallest, I'm going to just say, smallest subnet is a /28, which give you 16 IPs total, but 11 to use. Okay. Cool. After creating Amazon VPC, you can add 1 or more subnets in each availability zone. Subnets reside within 1 availability zone and cannot span zones. So subnets cannot span zones, limited to 1. It's important to point that can come up on the exam. So remember that 1 subnet equals 1 availability zone. However, you can have multiple subnets in 1 availability zone. Okay. Wait, what? You can have multiple subnets in 1 availability zone. Okay. Multiple subnets within one AZ. Okay, I can do that. Cool. Subnets can be classified as public, private, or VPN only. A public is one in which the associated route table directs the subnet's traffic to a VPC IGW. See what I'm talking about? So this will be on the exam. It'll be something like Amazon VPC IGW. How does a public subnet correlate with this? It'll be something like that. And if you don't know, if you don't know what an IGW is, you asked out. A private subnet is one in which the associated route table does not direct the subnet's traffic to an internet gateway. What did I say an IGW was? Yeah, oh, that's right. Okay, an internet gateway. And a VPN-only subnet is one in which the associated route table directs traffic to the VPC, VPG, don't remember what that was. Wait, virtual private gateway, and does not have a route to the IGW. Okay, so I'm definitely gonna have to write that down because I have no idea what they're saying here. So subnets. Subnets can be public, private, what can I spell? Oh, my keys aren't working. Or VPN. Public equals, what did they say? Is one in which the associated route table directs the subnet traffic to the VPC IGW. Traffic routed to VPC IGW. Let's see, private means that it does not route it. No traffic to VPC IGW. And then VPN means where is it? A VPN subnet is one in which the associated route table directs the subnet's traffic to the VPG. Traffic goes to VPG. Cool. Let me check real quick how many pages are within this chapter, because I don't want this. Okay, cool. That's not that many. And again, I be skimming. So, okay. Is that about subnets? Cool. We were here, classified as public, private. Regardless of the type of subnet, the internal IP address is always private. So let's make that as a note. Internal, which makes sense. Internal, but I'll write it down anyway. IP address, range of subnet is always private. And the default VPCs contain one public in every availability zone within the region with a net mask of 20. So that means default is one public subnet in every AZ with a net mask of 20. Let me say net mask. Net mask of /20. Cool. All right, route tables. Good job, Dominique, for not skipping, because I definitely would have skipped all of this. Okay, so a route table is a logical construct within a VPC. It contains a set of rules, they're just called a route. They are applied to a subnet and they determine where traffic is directed. So route tables is super important to understand. A route table's routes are what permits an instance within different subnets within a VPC to communicate with one another. You can modify route tables. You can add your own custom routes. You can also route tables to specify which subnets are public, which is when IGW comes into place, and then which subnets are private, which means that traffic is not directed to the IGW. So each route contains a default route called the local route. So let's go back and let's see what can we highlight out of here. So a route table, like I said, it contains a set of rules that are applied to a subnet. So I'm going to just write that down. So route table rules are applied to subnet and they determine where traffic goes. Determine where traffic goes. Each route table contains a default route called the local route, which enables communication within the Amazon virtual private cloud that you have. And this cannot be modified or removed. So that's pretty important, because if they ask you a question like, hey, like, can you just delete a local route? You should know that, hey, local routes cannot be deleted. They are there by default. So tables have default route, which is called a local route, that cannot be modified or removed. Additional routes can be added to direct traffic to exit your virtual private cloud via your IGW or VPG or the NAT, which they're clearly discussing later. But they said you should remember the following points. So can I copy and paste that? Because I don't want to retype. Yes, you should remember the following route tables. Thanks. Oh, that didn't paste in the way that I want to. Okay, cool. So the first route is that you must have an implicit router. Your VPC automatically comes with a main route table that you can modify. You can create an additional custom routes table for your VPC. Each subnet must be associated with a route table, which controls the routing for the subnet. If you don't explicitly associate a subnet with a particular route, the subnet uses the main route table, which might not be what you want, especially for security purposes. You can replace the main route table with a custom table that you've created, so that way each new subnet is automatically associated with it. Each route in the table specifies a destination CIDR. For example, traffic destined for 172.16.0.0/12 is targeted for the VPG. Now that's a lot, but again, I just wanted to, if these are important points that the book is calling out, usually, again, what I would do is write these down and then come back to them later, because a lot of the times you can, especially if you're studying a bunch of chapters at once, if you're studying a whole bunch of things at once, it can be difficult to kind of retain information. I get brain fried. So what I usually do is, again, highlight what I think is important that I might not remember later, or that might be a little bit difficult for me to recall on the test. And therefore, when I'm studying each week, because I'll look over my notes each night, then I'm starting to kind of embed this information into my memory. Cool. Is this still a thing? It is. All right. What's next? Internet gateways. Internet gateways. I might have to put my headphones on anyway, because my mom and my brother went to go play tennis, and they will be back soon. So get out the way. An internet gateway is a horizontally scaled, redundant, and highly available Amazon VPC component that allows communication between instances in your VPC and internet, which is super important, what they said already. Horizontally scaled. Can I spell? I cannot. Horizontally scaled, redundant, highly available. Communication between instances and the internet. So this is how an internet gateway is how your internal instances is going to be able to talk, get data, process XYZ to the internet. An IGW provides a target in your VPC route table for the internet routable traffic, and then it performs a network address translation for the instances that have been assigned that public IP address. An EC2 instance within a VPC are only aware of their internal private IP addresses. So when traffic is sent from an instance to the internet, the IGW, or the internet gateway, is what that translation is doing. So it's the one that's translating the reply address to the instance's public address, and then it's maintaining that mapping, which means it's, so for example, if you have a virtual machine that is talking to the internet, it's maintaining that connection for you. So you must be willing to create a public subnet. I'm going to copy this as well. Anything that says like you must do this or you must have that, I highlight as pretty important. Is that going to stay under there? Okay, cool. Cool. Make that bold. Make that a bullet. And I'll delete this. Okay, cool. Let's make this a little bit more organized. Cool. So what you must do is you must attach an IGW to your VPC, which makes sense in order for it to talk out to the internet. You must create a subnet route table rule to send all your non-local traffic information to the IGW. And then you must configure your network access control list, which is an ACL, and your security groups in order to allow relevant traffic to flow from your instance. So not only do you need to attach an internet when you're creating a network in AWS, not only do you need to make sure you have an internet gateway attached, which was the first rule, you also must create a subnet route for this for non-traffic, and you also must configure your network ACLs and your security groups. Those are super important that a lot of the times people leave as default, and the default, again, might not adhere to either what you need or it might be too restrictive, right? You just need to make sure you're looking at all the different components. And you also must do the following in order to enable it to send traffic is you must assign a public address or an EIP address. So I'm gonna make that as a note. Oh, did I not copy it over? What did I just do? Okay, yes, I did. Cool. What's next? This is an example of a VPC, a subnet, a route table, and internet gateway. So again, we have our public subnet here, which is the 10.0.0.0/24. And then this is within an availability zone A. We have our router attached with our internet gateway, which is attached to, I'm assuming this is the internet as a cloud. And then you have our VPC, which encompasses this entire thing. So this entire thing is our virtual private cloud. We have our network within it, and then all of this is within an AWS region. So we're kind of getting a little bit deeper. As you can see, our architecture from before is getting a little bit more complex as we start to add some more components. DHCP, Dynamic Host Configuration Protocol. What do we need to write down about this one? All right, DHCP provides a standard for passing configuration information to hosts on a TCP IP network. And the options field of a DHCP message contains configuration parameters. Some of these parameters are domain name, the server, your net BIOS. So AWS automatically creates and associates a DHCP option for your VPC, which is good to know. So that is already created for you by default. And it sets two options. You have a domain name server, and a domain name defaulted to the domain name of your region. Amazon provided DNS is an Amazon Domain Name System server, or DNS server, and this option enables DNS for instances that need to communicate over the VPC IGW. Now that was a lot of information. So what we can take away from this is you definitely need to know the definition. So again, a DHCP is providing a standard for passing configuration information to hosts on a network. So I would have that definition just to make sure I am aware of that. And then from here, the options contain different configuration parameters. I'm not sure if they would ask you that on an exam. We'll see if we go into the summary. Is automatically created for you, which is something I can remember. It does have two sets of options, so I would want to write that down. So 2 sets of options automatically created, which are your domain name service, which is called this. Yes, it is. So you said you never seen this on the actual AWS test, or are you saying that you've never seen this like on any test at all? But it definitely does have real world application. DHCP networking is huge, no matter if you're on premise or in the cloud, simply because I would say the cloud is still the same. It's just that you're not hosting your own on-premise data center, right? It's still a data center somewhere, and it still has architecture and things that you need to know, which is why being an architect is a really important, critical job. So learning about networking and DHCP and IGWs and subnets and all these other acronyms are super important. Oh, she said, okay, not on the AWS Solutions Architect, but it won't be. Okay, cool. So what we said, the two options, the first one is domain name service, and then we have domain name, which is defaulted to your region. All right. And DNS is in DNS server. This enables DNS for instances that need to communicate over the public internet. So like whenever you start to, which I don't know if anyone else does, but as you start to learn different terminology, different acronyms, so like I can read this sentence a little bit better because now it's saying, now that I know what provided DNS is, I know what IGW is, it's saying that the DNS server that is defaulted it enables your instances, so any of your virtual machines, any of your resources, it allows it to communicate to the internet. So whenever you see Amazon VPC IGW, essentially what that's saying is I'm connected, or I'm able to talk to the internet, because that's what that is. And IGW is the gateway between your internal environment and the the internet. I like drew a blank right there. Okay. DHCP options, the elements that allow you to redirect your host name assignment to your own resources. To assign your own domain name, you can to your resources. You have to create a custom DHCP option, assign it to your VPC, and you can configure it with the following options. So the fact that they have options makes me think that that's something pretty important to remember. So I'm going to write that down. So these are the different options. I want to copy that. And I will have that as a note. Why does it say separated by commas? Oh, there we go. And then one last note that I see that they have here is that every Amazon VPC must have only one DHCP option set assigned to it. I'm pretty sure that would be maybe a question. All right, Elastic EIPs. Let's say how much we have to. I might skip a couple just because I know we're coming up on an hour. And then maybe I'll come back tomorrow and answer some questions. So we have Elastic EIPs. So actually I'll do that. I'm gonna go over, yeah, I'll come back and do questions for it. So we're gonna do EIPs. And I already wrote down what an EIP is before. AWS maintains a pool of public IP addresses in each region and make them available to you, the customer, to associate resources within your VPC. An Elastic IP address, which is an EIP, is a static public address in the pool for the region that you can allocate to your account and release. So I'm going to put that down because that is the definition of an EIP. Yeah, I'll take that. Now, EIPs allow you to maintain a set of IP addresses that remain fixed while the underlying infrastructure may change over time. So to me, this is similar to, this is just a static IP, and they're calling it Elastic IP instead of static IP, because you have static and you have dynamic IP addresses. So I'm guessing for naming convention purposes that they're calling it Elastic, but this is it's just a static IP address. And here are some important points. I appreciate them for highlighting that for me because that makes my life a little bit easier. Here are important points for the exam. Ma'am, why aren't you letting me highlight? Okay, and let's bullet. Every time I think of bullet, I just think of I have a friend back in college who she's Jamaican and all she was bullet. That reminds me of her. I don't know why. Okay, cool. EIPs. So within EIPs, you must first allocate an EIP to use within a VPC and assign it. They have to be specific to a region. There's a one-to-one relationship between network interfaces and EIPs. You can move them from one instance to another, either in the same VPC or a different VPC, which is good to know, but it must be within the same region. They remain associated with your account unless you explicitly release them. So that was a question that was on the past practice test as well, because it was asking if you delete, or it was something similar where like if you delete a virtual machine, will the IP address still be associated with your account? Something of that nature. And there are charges for EIP allocated to your account, even when they are not associated with the resource, which is important. Why this note is important, because most people, you might think that, oh, I no longer need this, but I didn't explicitly release it, and therefore I'm still going to be charged for it month after month, which can be kind of like a hidden cost. You have elastic network interfaces, which is a quick one. ENIs. ENIs is a virtual private network interface that you can attach to an instance in an Amazon VPC. So I'm just going to take that definition and kind of leave it at that, because I see that these are really short and they're kind of just highlighting the important ones that we need. ENIs are only available within an Amazon VPC, and they're associated with the subnet upon creation. They can have one public IP address and multiple private ones. So that's a pretty good, important note. If there are multiple private IP addresses, one of them is a primary. If you assign a second network interface, the ENI allows it to be a dual homed. So I'm going to put that you can assign a second network interface. They can have an IP address. ENIs allow you to create a management network, use network and security appliances in your Amazon VPC. You can create dual homed workloads, or create a low budget, high availability solution, which is pretty good, because I'm pretty sure they'll ask you that too. Like, what kind of environment, what is this used for? All of that nature. Endpoints. Endpoints like regular endpoints. An Amazon endpoint enables you to create a virtual private connection between your Amazon VPC and another AWS service without requiring access over the internet or through a network address translation instance, a VPN connection, or a direct connection. So essentially, I think an endpoint just enables you to have a private connection without you needing any other Amazon resource, which I don't know why they couldn't just say that, but I guess they're trying to like hit home that you don't need that. So this enables you to privately talk. Okay. You can create multiple endpoints for a single service, and you can use a different route table to enforce different access policies from different subnets to the same service. I will write that down, because I'm pretty sure that's not a note that I would really remember. So I'm going to bullet these 2 points. Now, a VPC endpoint currently supports communication between a S3 and other services to be added in the future. And you must do the following. So I'm going to highlight the following. And I'm pretty sure underneath it are just examples of like what they're trying to say that we should highlight. Again, I always encourage, like when you're doing notes, especially if it's a subject that you're not familiar with, it's better to write notes than to have to go back and like read the textbook all over again or figure out where you are. So for like this chapter in particular, like typically I don't really write that many notes, especially if it's something. So I've been working in cloud, so it's pretty familiar with me. But for this one, I'm not really good with networking at all. So I would need to know each one of these. And like, I want to get to the point, I would get to the point where as my notes are, which is why I like Notion. So if I see a subnet, I should be able to know the talking points of a subnet, the talking points of a route table, of an IGW, DHCP. Like every time I see these acronyms, I should be able to speak to it. And then I have my notes underneath to help me reference. And then I'll just keep reading these night after night until I can say, okay, an EIP is a static IP address. EIPs are the same thing as static IP addresses. Or endpoints. Endpoints allow you to talk allow your instances privately to talk within a VPC without having to need extra Amazon services. So that is the goal of me writing my notes this way, just so that way I can start the memorization process and then figure out what these are. Peering. We are getting towards the end here. So here, peering. A peering connection is a networking connection between two Amazon VPCs that enable instances in either VPC to communicate with each other as if they're in the same network. So I pretty much know about peering. So for me, I can just say connect to VPCs to talk. I don't really need that much because I'm pretty familiar with how peering works. You can create a peering connection between your own Amazon VPC or another one within a single region. Okay, so that's good to know. You can only do it within a single region. Okay. Can peer within a single region. And a peering connection is neither a gateway or VPN connection, does not introduce a single point of failure. So that's also something I would highlight. If it says it does not introduce a single point of failure, because you can have a question perhaps, or this is just something for reference where if someone in your architecture, you say, I want to set up a peering connection. I want to set up an environment that allows my virtual private clouds to talk to one another, but I also want to make sure it's not a point of failure. And if that, say, for example, if that was a question and then a peering option was one of the options, in my mind, I could say, a key term was it doesn't want it to be a single point of failure. As it says here, a peering, it does not introduce a single point of failure for communications here. So that was something that I would put on there. So peering connections are created through a request accept protocol. The owner of the VPC needs to send a request to the peer. If it's within the same account, it's identified by an ID. If it's for a different account, they would need an account ID and a VPC ID. The owner has 1 week to accept. You can have multiple peering connections, and peering is a one-to-one relationship. So let's put that. You can have multiple peers, and peering is one-to-one. I don't know how to spell still. Peering connections do not support transitive routing. Okay. That's a good note. Does not support transitive routing. So transitive routing set is depicted here. So transitive routing would be, well, if VPC A is connected to VPC B, the VPC B is now automatically connected to VPC C. Transitive would means it's kind of like an inherent trust thing, where if I trust one network, that means another network that's also connected to me should trust that one. Not necessarily the case, which is good for security purposes, because then you can allow another network that you didn't explicitly accept or allow to come into your network. All right, these things here are the important points to understand. So I'm going to highlight these points. Highlight points to remember. You cannot create a peering connection that has overlapped CIDRs. You cannot create one in different region. Does not support transitive routing, and you can't have more than one peering connection at the same time. All right, security groups is something I am familiar with, but let's see if maybe there's a question I need. I mean, a question, an important concept. So security group, virtual stateful firewall that controls inbound and outbound network traffic to AWS resources. All instances must be launched into a security group. If it's not specified, then the default security group will apply. And the default security group allows communication between all resources within the group, allows outbound traffic, and denies all other traffic. That's definitely a question I have seen before, where it has asked what is the default pathways for your security groups, or I should say, what is the default pathways for a firewall? And you have to figure out what's in order. Like, does it explicitly allow, explicitly deny, XYZ, which firewall rules will outweigh another. So that's really important for you to keep in mind of when it comes to security groups. Like security firewalls, rules are applied in order. So whatever is at the top is going to take precedence over everything at the bottom, no matter if at the bottom you say you want to open port 80, for example. If at the top you say explicitly deny port 80, it's not going to go through. So you always have to make sure that whatever is your most restrictive rule, you're going to put underneath all of the other allow rules, because it's always going to override and allow with a deny if your deny is first. All right. So, dang, that's a lot of important points. Okay. So important points. You can create up to 500 security groups. You can add up to, which is, important, because that was also a question before. It's like, does it have a limit? I don't think it was about security groups. It was about something else, but it was asking, like if you spin up something in an environment, and it doesn't work out, what's the reason? And one of them was because it had a limit, which I didn't know. So it's good to know if you have 500 security groups. If you have 501, it won't go through. So there's a whole bunch of points here that I will highlight. And I will clean that up. It's clearly, if they're more than likely, if they're telling you like these are stuff to highlight, it's mainly because it's a question that they'll see, or just really good for your reference. Again, a lot of the times I know people kind of study these books as a way to pass a test, but it's also really useful information for your reference, for your job, for your role, right? You kind of knowing what the rules are of whatever environment or thing that you're spinning up. Cool. Knuckles. I think we're getting towards the end anyway. Knuckles. Network access control list, another layer of security that acts as a stateless firewall on the subnet level, which is good to note, right? That's at the subnet level. So I'm going to put that subnet level. ACLs is a numbered list of rules that AWS evaluates in order, similar to what I was just talking about before. When it comes to firewalls, they evaluate in order, starting with the lowest numbered rule to determine whether traffic is allowed in. So by lowest number, that's always going to be your 0. So 0 is always going to be your highest priority rule on your firewall. VPCs are created with a modifiable ACL associated with each subnet. You can create a custom ACL. Its initial configuration, again, will deny all inbound and outbound traffic until you create a rule otherwise, and you also need to make sure you put that rule above that one. All right, I already know about access control list. I'm going to leave it there and then maybe use the summary. I also know about network address translation, but we'll see if there's something that we need out of there. Okay, network address translation is an Amazon, that's an instance. Let's come back. By default, any instance you launch into a private subnet is not able to communicate with the intranet. This is problematic if the instances need direct access to the intranet in order to maybe get a security update, download patches, XYZ. You can use a NAT instance, and the gateway will allow a private subnet to gain internet access. So the main reason for this is to gain internet access within private subnets. The network address translation instance, Linux Amazon machine image, and AMI, another acronym, that is designed to accept traffic from instances within a private subnet, translate the source IP, and then forward that traffic to the IGW. So that's a pretty good concept for you to really understand like what's happening within network address translation from whether or not from my internal instances trying to talk out to the internet and how that works, right? Which services does it hit? How many services does this traffic need to hit between firewalls, network address translations before it actually gets out to the internet, and then once it comes back in? All right, we have the network address translation gateway, so NAT gateway, which is a managed resource designed to operate just like a NAT instance, but it is simpler to manage and highly available. All right, and then we have virtual private gateways, customer gateways, virtual and VPNs. I know about VPNs already, and I'm assuming the only difference between virtual private gateway and customer gateways, let's see, is it because one owns? So virtual private gateway is the VPN concentrator on the AWS side, and a customer gateway represents a physical device on the customer side of a VPN connection. That's what I thought it was, but I'll write down the concepts anyway. So a VPG, a CGW, and then a VPN. And let's put a bullet. So we're going to highlight what that one is. A customer one. And then the last step between those is the VPN tunnel, which is how you make the connection. All right, we reached the summary. So in the chapter, we learned about VPC as a networking layer for Amazon EC2, and allows you to create your own virtual private network within the cloud. You can provision your own logically isolated section of AWS. It consists of a subnet, a route table, DHCP, security groups, network access control list, which we covered. It also has some optional components that we went through. We learned that subnets can be public, private, or VPN only, and the differences between those. We learned about route tables. We learned about internet gateways. How can your internal traffic talk to the internet? We learned about DHCP options. Again, as you're creating your environment, each service kind of layers on top of it in order to provide different access to different things or different ways for your traffic to flow. We learned about the EIP, which is static IP address, public IP addresses. We learned about endpoints for private connections between your VPC without requiring access to the internet. We learned about peering connections, security groups, networks access control lists. We have a NAT instance, the NAT gateway, the VPGs, the VPNs, CGWs. I can go on and on. I so much should create a rap song with all these damn acronyms. So some exam essentials, what a VPC is and its core components, which we went over. The purpose of a subnet, which is to segment a VPC's IP address range for isolated resources. So for example, if you want to separate your HR from your security team, from your developers, from your marketers, XYZ, having a subnet can allow you to kind of break that up and provide isolation within your network. Understanding different public subnets, private and VPN only, the purpose of a route table, the purpose of an internet gateway, which again, for you to be able to talk to the internet, you definitely need to attach an IGW. So that's super important for a question that requires you to figure out whether or not you need to just talk internally or if you need to talk to the internet. Understanding what DHCP options are, the difference between a VPC public IP address and EIP, which is again, static. See, I need to go back and reference some stuff. Understand what endpoints are, which is the private connection without having to reach out to the internet. Boom, see, without requiring access over the internet, I'm already learning. Understand VPC peering, which again, you can talk to, enable two VPCs to talk to one another within the same availability zone. I remember that, or region, one of those. Oh, within the same region, see? Know the difference between a security group and a network access control list, right? Both of those are pretty stateless firewalls, but a security group is at the instance level, whereas if I'm not mistaken, network access control lists are at the subnet level. So you can have multiple instances in the subnet. Security groups are stateful, but network access control list is at the subnet level. Understand what a NAT provides to an Amazon VPC, and understand the components need to establish a VPN. Now, there are some exercises and some questions. So I agree with them. The best way to become familiar as a VPC is to build your own. So what I'm going to wind up doing is for these exercises, I'm going to do that as a separate video because that's going to be for my Patreon. So I'm doing a whole bunch of cloud demos for Patreon. And I might do some that I can broadcast, but I kind of have a little bit more flexibility of like when I can record at least outside of like the Mondays that I've associated with, because my week gets kind of busy as the days go on. So yeah, I'm going to record creating a custom VPC. Like as we go through each chapter, I'm going to create an associated video for it. So whether or not I do stream or not, I'm always going to put it on my Patreon, so you can definitely access it and see it there. But I am going to come back later on this week because I would like to go over the questions. So if you did follow along for today and you are reading and you're following along with like the chapters, because again, I'm doing chapter 4, 5, and 6 today. I mean, not today, 4, 5, and 6 this week. I'm going to do chapter 4 questions on live, probably tomorrow. It might just not be at 4 o'clock. It might be a little bit earlier, but I'll post it and tag it at the top of my Twitter page. And then Sunday is going to be chapter questions from 4, 5, and 6. So if you are in that study group, you have a warning now that these are the questions that are going to be in that practice exam this Sunday. So I hope you're prepared and I hope you're reading. And this will give you just kind of a good indication of where you are, kind of thing. So thank you for following along if you're still here. I hope you learned something about networking. I know I have, because again, networking is not my strong suit. But it is important in the realm of cloud and like security and all that kind of good stuff, because there's no way you can understand how to secure something if you're not sure how it's architected, how it's created, how all the different services really talk to each other, how your data flows within your network and your environment. So understanding this is super, super critical, not just really understanding, oh, well, how does the security service work, or how does this security product work? It's important, I think, to be a well-rounded security person, you should really, really know about networking, which is why I always kind of go back and refresh and figure out what can I learn. And you can do that through certifications or studying on your own or really hands-on practice, all that kind of good stuff. But we're approaching an hour. I will be back sometime tomorrow. Yeah, I'm going to do it tomorrow, because if I don't do it tomorrow, then I'm going to forget everything. And this would be good practice, right? So I'm going to review my notes tonight. Hopefully I remember everything. And then tomorrow we can answer some questions. I already think the minimum size subnet you can have in a VPC. Already I don't remember. Already I don't remember. So I'll be back tomorrow. Thank you so much. Bye.